All right, let's dive in. Today, we're going to pull back the curtain on something that powers our entire digital world, real-time data streaming. We're going to break down exactly how massive amounts of information get processed the very second they're created. The magic that makes everything feel so instantaneous.
I mean, have you ever gotten one of those fraud alerts on your phone, like right after a weird transaction happens? Or maybe you've watched a delivery driver's little icon just smoothly move across a map. Well, guess what? That's not magic. It's the power of processing data as a continuous, non-stop flow instead of in big, clunky, delayed chunks.
So, to really get why this is such a big deal, you kind of have to understand the old way of doing things. For years, the standard was to just collect data in these giant piles, waiting hours, sometimes even days before doing anything with it. But now, the game is totally changed. We're talking about analyzing data the very instant it shows up. Okay, so the huge difference here is between what we call batch and streaming. Batch processing, that's like saving up all your laundry for Sunday, right? You get this huge pile and you do it all at once. It works, sure, but you gotta wait all week for clean clothes. Streaming is the complete opposite. It's like washing a shirt the second it gets a stain. It's all about handling data while it's in motion as it's being created. And this simple change cuts the time it takes to get an insight from hours down to milliseconds.
So, just how fast are we talking about here? I mean, seriously, we're talking milliseconds. You've got frameworks like Apache Flink that can get latency well under 100 milliseconds. And others like Kafka Streams or Spark Streaming are in that sub-second range. That's a delay so short, you literally can't perceive it. It's invisible. And the goal is always, always to push that delay closer and closer to zero.
Okay, so how does this whole thing actually work under the hood? Well, the best way to think about a streaming pipeline is like a digital assembly line, but for data. Each station, or stage, has a very specific job to do, and they all have to work together, perfectly in sync, to turn some raw piece of data into a super valuable insight instantly. This whole data journey really has 4 key steps. It all starts with the producers, which are just the source of all the data. Then it flows into a messaging system, something like Apache Kafka, which is kind of like the central nervous system. From there, a processing engine like Spark Streaming does all the heavy lifting. And finally, all that processed data lands in what we call sinks, which is where it becomes useful. Let's break each of these down. First up, you've got the producers. This is where the data is actually born. So think about IoT sensors on a giant machine, or every single click you make on a website, or even just the logs from a mobile app. Each one of those little actions creates a tiny piece of data, an event, that gets shot out into our pipeline to get processed. Next, all that data flows into Apache Kafka. And really, Kafka is the heart of pretty much any modern streaming system. Just think of it like a super fast, indestructible post office. Every event gets logged in order, and it can never be changed. This makes it the system's single source of truth. And the best part? It can handle millions of events per second, acting as this crucial buffer so the processing engine doesn't get totally overwhelmed.
And now for the brains of the operation, Spark Structured Streaming. Spark connects right to Kafka, pulls in that constant stream of events, and then does all the complex stuff. This is where you might calculate a running average, or spot an anomaly that looks weird, or even enrich the data by combining it with another stream. Like, imagine joining real-time click data with customer info to personalize an offer on the fly. That happens here.
Finally, after Spark has worked its magic, that valuable processed information needs to go somewhere. It needs a home. And that's the sink. The data could get written to a blazing fast database like Cassandra to power a live dashboard, or maybe it gets sent to a system that fires off an alert right to your phone. This is the moment where raw data becomes a real, actionable insight. All right, enough theory. Let's make this totally concrete with a real-world example. Let's say you're a company that monitors huge industrial machines with IoT sensors, and your goal is to predict when a machine is going to fail before it actually breaks and costs you a ton of money. So this is what that raw data coming off of the sensors might actually look like. It's just a non-stop stream of events. Each one has an ID for the specific device, a super precise timestamp for when the reading was taken, and then the measurement itself, in this case, the machine's temperature.
But here's the thing. The real world is messy. I mean, really messy. In these giant distributed systems, data doesn't always show up in perfect order. Networks can be unreliable, and computers, well, they can crash. So a truly solid streaming pipeline has to be built to handle all of that chaos.
And this brings up a huge question. What happens if a sensor's internet connection just drops for a few minutes? And then, all of a sudden, it sends a whole bunch of old data. If we're trying to calculate averages over time, this late data could completely wreck our results.
So, how do we handle that?
So check this out. Let's say we're calculating the average temperature every 10 minutes. At 11 a.m. sharp, the system calculates the average for the window between 10:50 and 11. But then, 10 minutes later, a piece of data from 10:53 finally shows up. It's too late. The window is closed, it completely missed the calculation, and now our average is just plain wrong.
The solution here is a really clever idea called a watermark. With a watermark, we basically tell the system, hey listen, I expect some data might be late, so just hold on for a little bit before you finalize things. So we might set a 10-minute watermark. That tells the system to wait until it sees a piece of data from 11:10 before it closes out that 11 a.m. window. This gives our late data from 10:53 plenty of time to arrive and get included. And the result? We get the correct calculation.
And what about failures? Like, what if the whole processing engine just crashes? That's where checkpointing comes in. A checkpoint is literally like a save point in a video game. The system is constantly saving its progress, what data it's processed, any calculations it's in the middle of, everything. So if it crashes, it just reboots from the last checkpoint. No lost data, no reprocessing stuff it already did. It's brilliant. So now we've got a tough, resilient, real-time pipeline that can handle the messiness of the real world. Now for the fun part. What kind of incredible things can we actually do with this? Because the applications are already changing everything.
You need to stop financial fraud before somebody loses money? This is how it's done. Analyzing and blocking transactions in milliseconds. Want to prevent a factory from shutting down? This is the tech behind predictive maintenance. And yeah, this is what powers those live business dashboards and the recommendation engines that seem to update with every single click you make online.
This quote really just nails it. It says that in a world where real-time insights give you a competitive edge, picking the right tools is all about matching the tech to what your business actually needs. It's not just about being fast for the sake of being fast, it's about using that speed to make smarter decisions right now. So there you have it. We went from a simple sensor reading all the way to an actionable insight, basically in the blink of an eye. The tech behind it is complex, sure, but the big idea is actually pretty simple. Make decisions at the speed of data. So now that you know how the architecture of now works, the only question left is, what would you build with it?